Hello students, in today's class we'll discuss about inverse trigonometric functions. Before starting inverse trigonometric function, let us quickly recall inverse of a function. We know for every bijective function f maps a to b. Bijective means 1 1 on 2. Bijective means 1 1 on 2. For f maps a to b bijective, there exists a function g maps b to a such that g of y is equal to x if and only if and only if f(x) equal to y. Then g is called inverse of x. Then g maps b to a is called inverse function of f maps a to b, and we denote f inverse is equal to g. Is that f inverse is equal to g. As a result, we can say f inverse of y is equal to what? Let's say by composition of function f inverse y is equal to f inverse y. So f inverse y is equal to f of x, which is equal to 1. So f inverse is identity function, and f inverse of f x is equal to f inverse fx is equal to, it is equal to f inverse y, and which is equal to fx equal to y, and inverse y is equal to x. So in this way we have defined inverse function. Now let's consider the function f maps R to R such that fx is equal to sin x. Fx equal to sin x, or which equal to say y. So we can say sin x equal to y. Then domain of sin x is R, and codomain of sin x function is also R. So obviously from graph, if we look at the graph of this sin function, it goes like this. Here plus 1, here it is minus 1, here it is minus pi by 2, plus pi by 2, pi, 2 pi by 2, and so on. So what do we see? This function is not 1 1 as well as not on 2, because if we draw a parallel line here with x-axis, then it is cutting the graph at more than 1 point, so obviously this function is not 1 1, and this is not on 2 because here if the value of sin x say, if we say y is equal to 2 3, then there is no pre-image of y, so therefore the function is not on 2 as well. So we can make this function on 2 by confining the codomain to its range itself. So range of this function is -1 to +1. -1 to +1 is, so this function in f maps r to -1 +1 fx equal to sin x equal to y. This is now not 1 1, but it is 1 2. Now we can make this function 1 1 again. This function can be made 1 1 if we confine the domain also. Confine the domain. You see in the graph, this is the graph. So if we take this portion only, here to here, that is -π/2 minus π/2 to plus π/2 domain, then this graph attains all the position, all the heights, all the values of y it attains. So this function is 1 1. In this case, this function becomes 1 1. Fx becomes 1 1 if we restrict the domain. So f maps, if we change it to -π/2 to plus π/2, and range becomes codomain, so -1 to +1, then this is 1 1 1 2 function. This becomes 1 1 1 2 function if fx is equal to here sin x. This sin x becomes 1 1 1 2 function, and in that case it becomes invertible, because for every 1 1 1 2 function there exists an inverse. So we define the inverse like this, and we denote it by sine inverse. So sine inverse, something like this. Sine inverse function is a function from -1 +1 to -π/2 to plus π/2. This function is defined as the sine inverse function. Sine inverse of y is equal to x if sin x equal to y. So y is a element, or we can say this one, we can change it. Sin inverse x equal to, if we like this, sin inverse x equal to theta if sin theta is equal to x. Sin theta is equal to x, where theta lies between theta, where theta is here, theta belongs to -π/2 to plus π/2, and x belongs to -1 and +1. Now from graph we see that this function is, after making the sine function onto, now this is called inverse function, sine inverse function. Now one thing we can note here, you see, if we change the f inverse, sine inverse function, if we define it from -1 to +1 and π/2 to twice π/2, then also it is 1 1 as well as 1 2. Here the domain range of this function is changing. Range of this function is changing, something like this. We can change it like thrice pi by 2 to 5 pi by 2, or you can say minus thrice pi by 2 to minus pi by 2, something like this. In this way we can have many ranges of this function, many range. Among this particular range, minus pi by 2 plus pi by 2, when sine inverse function has got this domain and this range, it is called principal value branch. This particular branch is called principal value branch if domain is minus 1 to plus 1 and range is minus pi by 2 to plus pi by 2, because range can be changed. But if range is this one, then sine inverse function has called principal value branch. This branch here, this domain and range is called principal value branch of this sine inverse function. Now let us look at the graph of the sine inverse function as well. Now minus pi by 2 plus pi by 2, here plus 1, that is minus 1. Now if we want to draw this is y equal to the sin x graph. Then if we change the x-axis and y-axis, x coordinate as y coordinate and y coordinate as x coordinate, then the graph becomes this one. Here it is pi by 2 minus pi by 2 minus pi by 2, here minus 1 and plus 1. So here graph goes like this. So the graph of these functions we will discuss again thoroughly in the next class, but we are dealing with only the sine inverse function and its definition in this class. Since sine inverse function is defined from where to where, sine inverse is a function from this domain is minus 1 to plus 1 and range here minus pi by 2 to plus pi by 2. This is the principal value branch. So this is its domain and this is its range. Domain and range of this function, sine inverse function, is this one. In the same way, we can define the domain and the range, that is principal value branch of the other trigonometric functions like this. The proceeding the same way. Cos inverse is a function from minus 1 to plus 1 and here domain is 0 to pi. Sorry, range is 0 to pi. And tan inverse is a function from r to minus pi by 2 to plus pi by 2. And cot inverse is a function from r to 0 to pi. Sec inverse is a function from R2 minus 1 plus 1, and the range is 0 to pi minus the element pi by 2, and cosec inverse is R2 minus 1 to plus 1 minus pi by 2 to plus pi by 2 minus the element 0. So these are the domain and ranges of the inverse trigonometric, 6 trigonometric inverse trigonometric functions: sine inverse, cos inverse, tan inverse, cot inverse, sec inverse, and cosec inverse. This is their principal value branch, domain and range. So you have to remember this domain and range, because if nothing is, no domain and ranges are written in the question, then we consider domain and range this only by default. So when we work out the examples, we have to consider the domain of the sine inverse function is minus 1 to plus 1, and range is minus pi by 2 to plus pi by 2. For cos inverse, it is minus 1 to plus 1, and range is 0 to pi. The same way, these are the domain and ranges of other inverse trigonometric functions. So you have to remember this inverse trigonometric functions domain and range. These are very important. Okay, let us work out some 2-3 examples. So how to use them? So sine inverse, find sine inverse half. Principal branch, principal value sine inverse half is equal to what? So sine inverse half, we start like solution. Let sine inverse half is equal to x. So this implies sin x equal to half. Sin x equal to half. So this implies sin x equal to sin, or you can write that this implies, therefore x equal to pi by 6, and pi by 6 belongs to this interval minus pi by 2 to plus pi by 2. So therefore sin inverse half is equal to x, and value of x is pi by 6, so answer is pi by 6. In this way we work out example. Suppose this is minus, suppose this is, say, sine inverse, say, root 3 by 2. So let us find out sine inverse minus root 3 by 2. So same way solution, let sine inverse minus root 3 by 2 is equal to x. So this implies sin x is equal to minus root 3 by 2. So this implies sin x equal to minus sin pi by 3. So this implies sin x equal to sin of minus pi by 3. So therefore x equal to minus pi by 3, and minus pi by 3 belongs to minus pi by 2 to plus pi by 2. So therefore that falls in the principal value branch. So therefore sin inverse, therefore sin inverse Sin inverse. So sin inverse minus root 3 by 2 is equal to minus pi by 3. Let us try another one. Cosec inverse 2. Find the value of cosec inverse 2. So we let cosec inverse 2 is equal to x. So this implies cosec x is equal to 2. So this implies cosec x is equal to cosec pi by 6. So this implies x equal to pi by 6. Pi by 6 belongs to this closed interval minus pi by 2 plus pi by 2 minus 0. In principal value branches belongs, so therefore cosec inverse 2 is equal to pi by 6. So in this way we can work out some simple problems. Okay, so you by heart, mainly you have to by heart the principal value branch. You remember the principal value branch is very important, so you by heart the principal value branches. Okay, thank you.